Okay, so minus 150 multiplied by 0.9. It's so critical to know your distance. If not, you multiply the wrong one, again, your answer will be wrong. And then the 500 will be positive. Right? Then plus by, okay, then plus by 0.9 and plus by 250 multiplied by 0.9. Okay. So this will be equal to minus 150 times 0.9 plus 500 times 0.9, 250 times 0.9 is equal to 540 pound-inch positive. Okay, and then we know right-hand rule, this is our positive direction. In fact, I should be writing this way also. So we know that this, right, this is going to be of positive. Okay, so we know now. Okay, so this has been confirmed. So what do I mean this has been confirmed? So we know that over on top MZ is going to be compression. Below MZ is going to be tensile. Okay, so again, from here, we have to find IZZ. So anything that's parallel to the axis, which is the width, any geometry that's perpendicular, this is going to be the what? The depth. Okay, so the width is equal to 4 multiplied by 1.8 cube divided by 12. You can't go wrong. Okay, so it's equal to 1.944 inches to cube. Right. So we are now going to find the stresses at point A, point B, and point D. Okay. So I'm going to transpose this. Okay, go on. Okay, so if we were to look at the question, point A, point B, and point D. So this is our point A, point B, and this is our point D. So from here, I'm going to draw our moments. Okay, so this is our orange. Okay, so this will be our my. Okay, so this will be compression. This end will be what? Tensile. Okay, and then we're going to draw our mz. Okay, so right hand rule. Right, so this is our mz. Compression. That is our what? Tensile. Okay, so from here we can find our stresses at A, B, and D. Okay, by just looking at this analysis diagram. Okay, by just looking at this analysis diagram. So we are going to look at stress X. I'll write down the formula first. Okay, so it's P over A. Okay, so as I said, not to worry about my over Iyy z. Is it positive or negative? Don't worry about that. Okay. Okay, so if we look at point A, okay, so put in the values first. Okay, so stress X at point A, right? So Px over A, I think we calculated. So Px over A is the same for everyone. 125. Okay, 125. So the next thing, you put your my over I. So if you look at point A, okay, moment about y is going to be tensile. Okay, so plus, so my, we calculate my is equal to, I think it's 900. 800, sorry. My is equal to 800 over IYY is 9.6. Am I right? IYY is equal to 9.6. Yeah. Now the thing will come, you will see the Z direction. So what is the Z direction? Okay, so Z direction is this point over here. Up to where? Up to here. Okay, don't confuse with the Y direction, because if we look at draw our transformation, okay, a lot of times students get confused. This is our Y direction, X direction. Okay, so X distance is running horizontally, and the X distance over here, right? So I'm going to draw over here, right? So our X distance, sorry, Z distance is equal to 2, right? Our Y distance is equal to 0.9. Okay, so you just need to put the Z distance to be equal to 2, right? Don't need to worry about positive 2 or negative 2, because down here by the tensile compression we saw everything out already. Okay, and then at point A, right, MZ is going to induce what? A compression. Okay, so minus by MZ, our MZ is equal to what? 540 over by IZZ. What is our IZZ? 1.944. Okay, so Y distance, so if you look at Y distance is equal to 0.9. Okay, so this will be equal to 125 plus by 800 times 2 divided by 9.6 is equal to 500 over 3 minus by 540 times 0.9 divided by 1.944 is equal to 250. So it's 125 is equal to 125 plus by 500 over 3 minus by 250 is equal to be 125 over 3, or 41.667 positive 41.667 psi. Okay, so that is for your point A. Okay, so stress X at point B. Okay, so this is also equal to 125, right? And then if you look at point B, right? Point B, right? My is going to induce a what? A compression. So this is minus, right? 800 multiplied by 2 divided by 9.6, right? And then at point B, right? At point B, MZ is also going to induce a compression. So easy, yes or no, right? The system that I've introduced is so easy. I hope you find it easy also. You just need to learn how to adapt to it, okay? Divide by 1.944. So this is equal to 125 minus by 500 over 3 minus by 250. Okay, so 125 minus by 500 over 3 minus by 250. So it's equal to minus 291.667. Okay, so that is our point B, minus 291.667 psi. So what you observe is between point A and point B, right, it goes from positive to negative. So the neutral axis will intersect on line point A and point B. Okay, so next we look at stress X at point D. 125 is the same for everyone. Okay, so My is going to induce a compression. Okay, so minus by 800 multiplied by 2 divided by 9.6. Right, MZ now, right, will induce a what? Tension. So it's going to be a plus. Okay, so that's why I keep on elaborating. Don't worry about the sign. When you analyze, the sign will come. You will see the shift in the change in the sign. Okay, so this is 1.944. So this is 125 minus by 500 over 3 plus by 250. Right, so this is equal to 125 minus 500 over 3 plus by 250. So it's equal to 208.333 psi. So you know that there's going to be a what? There's going to be another shift, right? Or the neutral axis will intercept point B to point D. Okay, that we know. Now, I'm not going to use the formula that they recommend, okay? I'm just going to use a very simple method, okay? Simple method in the sense that it's so straightforward, you can't go wrong, okay? So the next part, B, okay, B, we're going to find a position. Okay, we're going to find a position where the neutral axis intersect line A, B, D. Okay, so we know that we know our stresses. So I'm going to draw our stresses. Okay, so this is our point A, point B, point D. Okay, so we know our point A, we have what 41.667, positive 41.667. Point B is negative 291.667, and point D is positive 208.333, all in PSI. Okay. So as I said, we're going to use very simple math. Okay, for this, we are not going to apply the formula. Okay, we just do simple math. Okay, so we're going to look at between point A and point B. Yeah, we're going to look at between point A and point B. Or between line AB. All right, so we know that we do have a horizontal line. Okay, so this is point A, this is point B, and we are aware that at one end, right, you have 41. So I'm just eyeballing that this is 41. Okay, so this is 41.667, and then at the other end, okay, at point B, it comes down over here to 291.667. Again, this is a sketch of the stress distribution, right? So we want to find where this point is. Okay, where this point is. So I'm going to call the distance from, right? We're going to call the distance from here to here. This is X, okay? And then the distance from here to here is equal to 4 minus X. Okay, so all we need to do is find X, okay? And the entire distance is equal to 4, right? So to find X, so we just use gradient. They all lie on the same gradient, so it's equal to change in Y over the change in X, right? So the change in Y, the change in Y is equal to 41.667 divided by X, right? Change in Y, and then this will be equal to 41.667 plus by 291.667 and divide by 4. Okay, so we need to find X. So equal 4 times by 41.667 divide by 41.667 plus by 291.667 close bracket is equal to 0.5. Okay, so this is 0.5 inches from point A. Okay, straightforward, isn't it? You don't need to, I mean, there's a formula for it. If you want to do it, you can let this function, the whole thing is equal to 0. No, okay, let's do simple math. Okay, I mean, anytime I'll vote for simple. Okay, So likewise, between point B and point D, I'm just going to copy this diagram across the next page. Okay, so point B. Right, point B to point D. Right, so now we are going to draw point B to point D.